Okay, so we'll start our recording. Today is the 26th of September. You know that this shows what kind of velocity? Constant. And you further know that this shows what?
Acceleration.
Oh, smarty pants. Constant or changing? Changing velocity. So I met a physics teacher last year who said, oh, I don't let my kids say acceleration until I think they really understand it. So we talk about changing velocity, changing velocity, changing velocity, changing velocity a lot. I'm not that mean yet. Maybe next year. There's always hope. So you understand that changes in velocity are called acceleration. And let's talk about a few of the finer points of that concept. We said that velocity is a vector or scalar quantity. Do you remember this? Vector. Because it's got to have both a magnitude and a direction. So in this case, we've got an object, a vehicle, traveling 10 meters per second north. What if they make a 90-degree turn without slowing down, which would be a very bad idea, and are now traveling 10 meters per second? Well, if I've made that north, then that would be east. Talk at your table. Has this object accelerated? So they did, in fact, change velocity because they changed direction. Did they change their speed? No. Is this realistic? No. That's okay. The more traditional way to think about acceleration is changes in the magnitude of the velocity. So acceleration, we define it as the change in velocity over a given time interval. Delta V over delta T, V sub F minus V sub I over T sub F minus T sub I. We make liberal use of subscripts in physics, and they're really, really useful. When we get to relative motion, they become supercritical because we'll have like 3-word subscripts. It's kind of crazy. We can have negative or positive velocity. We can have negative or positive acceleration. In physics, we do not use the word deceleration. We just talk about acceleration. We talk about negative acceleration. We talk about positive acceleration. We don't use the word deceleration, generally. It's too fuzzy. It's fine for common everyday language, but it doesn't work in physics. In physics, we're just talking about the magnitude of the acceleration and the direction of the acceleration. It does have both a direction and a magnitude because it's a vector quantity, just like velocity was. So let's do a tricky thing. I have my little box car. It starts at 0. It starts at rest. It goes to 10 meters per second in 3 seconds. What is its average acceleration for that period? Acceleration average equals delta V over delta T. Delta V equals VF over VI. VF equals 10 meters per second. VI equals 0 meters per second. It's ridiculous that I'm writing all this out, isn't it? It's totally stupid. You don't have to write this stuff down, do you? Delta T equals 3.0 seconds. Yes, the evil laugh is write it down. Seriously. Write it down. Leave a breadcrumb trail. Because I'm a pain in your butt. That's why. So now we're going to actually plug it in and do math. I plugged it in. Acceleration average is 10 meters per second over 3 seconds. Do some dimensional analysis on that. What are our units for acceleration? Mine's bad handwriting, sorry. If we invert and multiply, yeah, meters per second times 1 over seconds. We had 2 sig figs, 3.3 meters per second squared is the average acceleration for this object. Okay, well that's easy. So that's a positive acceleration. It's going from 0 to 10. Easy peasy. What if we just reverse the problem and it's going from 10 meters per second to 0 meters per second in the same time period? Well, that's easy too. Average acceleration, delta V over delta t, acceleration average. I could cut and paste all of these, copy, paste. I'm just going to tuck them right there. Average acceleration equals 0 meters per second minus 10 meters per second over 3 seconds. And of course I screwed up all my sig figs here. But I get negative 10 meters per second over 3 seconds. What do I have? Negative 3.3 meters per second squared. Okay, negative acceleration, it's slowing down. Cool. Easy. Very, very easy. In years past, students have said, every time you say easy, that means it's going to get more complicated, which is true. But I'm not going to do that to you just yet. We'll do that to you tomorrow. So while I'm not going to make it more complicated today, what I'm going to tell you is don't trust those positives and negatives. The two examples we did, positive acceleration means it's speeding up. Negative acceleration means it's slowing down. It's not always the case. And a little later we'll look at when that's not the case. It's not that hard, but it does add a layer of complication. So right now we're going to look at page 49. We'll do the practice problem together. All of the 2B, or the sample problem together, all the 2B practice problems are assigned. And then we'll get through a few of those and I'll hand you the worksheets. Okay, so we've got a shuttle bus that slows down to a stop with an average acceleration of negative 1.8 meters per second squared. How long does it take the bus to slow down from 9.0 meters per second to 0 meters per second? How long does it take to come to a rest? So again, we're going to write down the equation. Average acceleration is equal to delta v over delta t. Vf equals 9.0. Oh, I'm sorry. Screwed that up already. Vf equals 0 meters per second. Vi equals 9.0 meters per second. And acceleration equals negative 1.8 meters per second squared. We are, in fact, in this case, looking for time. So I'm going to rearrange that. Did I mention yesterday that I will find some sort of, I don't know, plant material, wet noodle, something inedible to beat you with if I see you plugging in numbers to an equation before you rearrange it? Did I mention that? Should I mention it again? I'll mention it frequently. Rearrange before you plug in values. So, and I don't think any of you are in this boat, but I will also say that this particular three-part algebra solve is the most common mistake, even among really, really smart kids. If they don't do it the right way, they solve it wrong. Delta t equals delta v over average acceleration. And I think you guys can all do it, but if you need to show the steps, show the steps. So delta v is 0 minus 9 meters per second divided by negative 1.8 meters per second. Delta t equals negative 9 meters per second over negative 1.8 meters per second. Is that 0.2? I don't have a calculator. Is it? Oh, 5 seconds. Okay. Which is point. Never mind. That relationship only works in my brain. So I get a raw answer of just 5. To fluff that up to 2 sig figs, I do have to write 5.0. That's it. So with that, get moving. Start working on these problems. You got a few minutes and then you got 30.